Good morning, dear students. In this class, we will be studying about the quantity index numbers. Now, what is this quantity index number? Quantity index numbers is the study of changes in the volume of goods produced or manufactured consumed in the current period as compared to the base period. Previous classes you have learnt about price index number. This is quantity index numbers, which is the study of changes in the volume of goods produced or manufactured consumed in a current period as compared to the base periods. Now certain various methods are there. We will go one by one for the various methods. Now weighted aggregative index number. These are divided into 5 methods. Further, first one is Laspeyres quantity index number. Laspeyres quantity index number, it is given by Q01, which is equal to summation Q1 into P0 divided by summation Q0 into P0 into 100. Similarly, you have done in a price index number, that was Laspeyres price index number. Similarly here, Laspeyres quantity index number. Second one is Pasteur's quantity index number. Pasteur's quantity index number, that is Q01 is equal to summation Q1 into P1 divided by Q0 into P1 into 100. Pasteur's quantity index number is given by Q01 is equal to summation Q1 into P1 divided by summation Q0 into P1 into 100. Next, moving on to the Marshall-Edgeworth quantity index number, it is given by Q01, which is equal to summation Q1 into P0 plus summation Q1 into P1 divided by summation Q0 into P0 plus summation Q0 into P1 into 100. Next, going on to the Darvish-Bowles quantity index number, which is given by Q01, which is equal to half of Laspeyres quantity index number plus Pasteur's quantity index number. Further, we can also write it as Q01, which is equal to half into summation Q1 P0 divided by summation Q0 into P0 plus summation Q1 P1 divided by summation Q0 P1 into 100. And finally, there is Fisher's quantity index number. Finally, it is a Fisher's quantity index number. It is given by Q01, which is equal to square root of Q01 into Laspeyres quantity index number into Pasteur's quantity index number, which also can be written as a square root of sigma Q1 into P0 divided by summation of Q0 P0 into summation Q1 P1 divided by summation Q0 into P1 into 100. Let's move on to the example. Compute Laspeyres quantity index, Pasteur's, Marshall-Edgeworth, Darvish-Bowles and Fisher's quantity index number from the following data. So the data is been given, that is items are given, price with respect to the base year and quantity with respect to the base year, it is given. 2010 is the current year and price and the quantities of the current years are given. Now we will move into the solution of this problem. So we need to make the columns. So price, it is denoted as a P0 for the base year and quantity it is denoted as Q0. Here price, it is denoted for the current year as P1 and quantity has Q1. So similarly, we will make the tabular columns, that is commodity P0, Q0, P1, Q1. Next we need Q0 into P0. Q0 into P0 multiply Q0 into P0, that is 50 into 8, that is 400. 80 into 4, that is 32, 320. Next 70 into 6, it is 420. Next 30 into 5, it is 150. So here it should be 32, so it is 320. It should be 320 here, so correct it. So correct this value, it is 80 into 4, it is 320. Next multiply Q1 into P0. Q1 into P0, 60 into 8, it is 480. Next 100 into 4, it is 400. 60 into 6, it is 360. 50 into 5, it is 250. So in total it will give you 1490. Next similarly calculate Q0 into P1 as well as Q1 into P1. Now we will be applying one by one the formulas. So the Laspeyres quantity index number is given by Q01, which is equal to sigma Q1 P0 divided by sigma Q0 into P0 into 100. So sigma Q1 P0, it is 1490, and sigma Q0 into P0, so it is here, it is 1290 into 100, so which will give you 115.5. Next we will be applying the formula for the purchase quantity index number. So purchase quantity index number, it is given by Q01, which is equal to sigma Q1 into P1 divided by sigma Q0 into P1 into 100, which is equal to 1810 divided by 1530 into 100, which is equal to 119.30. Next we will move on to the Marshall-Edgeworth quantity index number. It is given by Q01 is equal to sigma Q1 into P0 plus sigma Q1 into P1 divided by sigma Q0 into P0 plus sigma Q0 into P1. Substituting, we will get, that is 1490 plus 1810 divided by 1290 plus 1530 into 100, which is equal to 3300 divided by 2820 into 100, which is equal to Q01, which is equal to 117. So the value of Marshall-Edgeworth quantity index number is 117.02. Next, moving on to the next formula, that is Darvish-Bowley's quantity index number, that is given as Q01, which is equal to half of sum of Laspeyres quantity index number plus Purchase quantity index number. So we know that Laspeyres quantity index number is 115.5 plus Purchase quantity index number is 119.30 divided by 2, which is equal to 234.8 divided by 2, which is equal to 117.4. Next, finally, we'll be solving with the Fisher's quantity index number, which is equal to square root of Laspeyres quantity index number into Purchase quantity index number, which is equal to square root of 115.5 into 119.3, which is equal to 117.38, which is equal to 117.38. Next, example 18. For the following, compute Marshall-Edgeworth, Darvish-Bowley's and Fisher's quantity index number for the current year on the basis of the following data. So the data given is commodities are given, base year, quantity is given, value is given, current year quantity is given, value is given. Base year quantity we can denote it as a Q0, whereas we are in need of a price of the base year. but price of the base year it is not given, so we need to calculate. So similarly here also in the current year quantity is given and value it is given of the current year, where we are not given with the price of the current year as well as the base year. So we will see the solution here. Now first we must convert the values as below and proceed to compute the quantity index number. First the value is equal to price into quantity. So value is nothing but the price into quantity is nothing but the value. Therefore, how to get the price? So price is equal to value divided by quantity. So if we divide value with quantity, we will get the price. So we shall see the next step. See now, the tabular column items, next is quantity of the base year. Next it was given value of the base year, that is Q0 into P0. Next given was a quantity of the current year and value of the current year. So first we will calculate P0. How to calculate P0? It is Q0 P0 divided by Q0. 350 divided by 50 will give you 7. 600 divided by 120 will give you 5. 330 divided by 30 will give you 11. 360 divided by 20 will give you 18. 40 divided by 5 will give you 8. Similarly, here you can calculate 420 divided by 60 will give you 7. 700 divided by 140 it is equal to 5. 200 divided by 20 is 10. 300 divided by 15 it is 20. 50 divided by 5 which is equal to 10. So you got P0 and P1. So you need to calculate is a Q0 P1 and a Q1 P1. Q0 into P1. Q0 is here and P1 is here. So 50 into 7 it is 350. 120 into 5 it is 600. 30 into 10 it is 300. 220 into 20 it is 400. 5 into 50 it is 5 into 10 it is 50. So in total it will give you 1700. Similarly calculate Q1 into P0. Now apply the formula, that is Marshall-Edgeworth quantity index number. So Marshall-Edgeworth quantity index number, it is given as Q01, which is equal to sigma Q1 into P0 plus sigma Q1 into P1 divided by sigma Q0 P0 plus sigma Q0 P1 into 100. So substituting, you will get 1650 plus 1670 divided by 1680 plus 1700 into 100, which is equal to 3320 divided by 3380 into 100, which is equal to 98.25, which is equal to 98.225. Next, moving on to the Darvish-Bowles quantity index number, and the formula is Q01, which is equal to half of summation Q0 into P0 divided by summation Q0 into P0 plus summation Q1 into P1 divided by Q0 into P1 into 100. So substitute, that is half into 1650 divided by 1680 plus 1670 divided by 1700 into 100, which will give you half of 1.9645 into 100, which is equal to 98.225. Next, it is Fisher's quantity index number, which is given by square root of Q1 into P0 divided by Q0 into P0 into summation of Q1 P1 divided by Q0 into P1 into 100, which is equal to, substitute the values, that is 1650 divided by 1680 into 1670 divided by 1700 into 100, which is equal to square root of 0.9821 into 0.9824 into 100, which is equal to 98.225, which is equal to 98.225. Next, compute an index number from the following data. Next example, there is compute an index number from the following data. Items are given A, B, C, D. Price of an articles in the current year it is given. Number of articles produced in thousands, base year, current year it is given. Given things are price of an article in current year and number of articles produced in thousands in base year as well as the current year. See here in the question, price of the current year it is given. So this is P1. Number of articles produced, that is nothing but the number of articles produced is nothing but the quantity. For the base year, that is Q0. In this current year it is Q1. So here the articles in the current year P1 alone are given along with the quantities. So quantities are given. So we can construct only purchase quantity index number. So we can construct only purchase quantity index number. So how to construct that? That is item P1, Q0, Q1. These are given. That is a price of the current year. Q0 is the quantity of the base year. Q1 is the quantity of the current year. So we need to calculate according to the formula, that is Q01 is equal to summation Q1 into P1 divided by summation Q0 into P1. So we need Q1 into P1. So calculate Q1 into P1 and we need Q0 into P1. So calculate Q0 into P1, add them, you will get the summation of it. So substitute it to the formula, you will get 2525 divided by 1830 into 100, which is equal to 137.98, which is equal to 137.98. Moving on to the next example, example 20. Given summation Q0 P0 is equal to 400 and summation Q1 P0 is equal to 500. We need to construct a suitable index. So Q0 P0 is given and Q1 P0 is given. So we need to construct a suitable index. So this Q0 and P0, Q1 and P1 resembles of the Laspeyres quantity index number. So we need to apply the formula of a Laspeyres quantity index. So Laspeyres quantity index, it is given as Q01, which is equal to summation Q1 into P0 divided by summation Q0 into P0 into 100. Q01 is equal to summation Q1 into P0 divided by summation Q0 into P0 into 100. So on substituting, 500 divided by 400 into 100, which is equal to 125. So Laspeyres quantity index number is 125. Next example 21. Given summation P1 into Q0 is equal to 265. Summation P1 into Q1 is equal to 260. Construct a suitable index number. Given P1 into Q0 is 265, P1 into Q1 it is 260. You need to calculate suitable index number. So this suitable index number is nothing but the purchase quantity index number. The suitable index number which we can apply is a purchase quantity index number. So that is Q01 is equal to summation Q1 P1 divided by summation Q0 into P1 into 100, which is equal to substitute, that is 260 divided by 265 into 100, which is equal to 98.11, which is equal to 98.11. Next is example 22. If Laspeyres quantity index number is 170.4 and purchase quantity index number is 171.6, find Dorbish-Bowley's and Fisher's quantity index. Now, dear students, they have given here Laspeyres quantity index number, that is equal to 170.4, and purchase quantity index number, that is 171.6. We need to calculate Darvish-Bowley's and Fisher's quantity index. So Darvish-Bowley's quantity index number, which is equal to half into Laspeyres quantity index number plus purchase quantity index number. So both the values are given, that is Laspeyres quantity index number is 170.4 and purchase quantity index number is 171.6. So substitute them, which is equal to 171. Similarly, we also need to calculate a Fisher's quantity index number. So this Fisher's quantity index number formula is Q01, which is equal to square root of Laspeyres quantity index number into purchase quantity index number, which is equal to square root of 170.4 into 171.6, which is equal to 170.99, which is equal to 170.99. Next, example 23. If purchase quantity index number is 320.4 and Darvish-Bowley's quantity index number is 342.2, then calculate Laspeyres quantity index number. So we know that the relation between Darvish, Laspeyres and purchase is given by Q01, which is equal to half of Laspeyres quantity index number plus purchase quantity index number. So substitute the given values, that is Darvish-Bowley's, it is 342.2. So substitute 342.2, which is equal to half into Laspeyres quantity index number is not given, so write it as it is, and substitute for purchase quantity index number, it is 320.4, which is equal to 320.4. So multiply the half to this side, so it will become 644.4, which is equal to Laspeyres quantity index number plus 320.4. Now subtract, you will get Laspeyres quantity index number, it is equal to 324, which is equal to 324. The last example problem, that is if Q01, that is Laspeyres quantity index number is 236, Fisher's quantity index number is 238, find purchase quantity index number. So you know the relation between purchase, Fisher's and Laspeyres, that is given as Fisher's quantity index number, which is equal to square root of Laspeyres quantity index number into purchase quantity index number, that is 238. Substitute 238, which is equal to square root of 236 into purchase quantity index number. So square on both sides, so 238 the whole square, which is equal to square root will go when you square, so 236 into purchase quantity index number. So you divide this and square, you will get purchase quantity index number, which is equal to 240.02, which is equal to 240.02. Next we move on to the value index number. So value index numbers are the index numbers of the total money value of transaction taking place over a period of time. Value index numbers are the index numbers of the total money value of transaction taking over a period of time. So the value is the product of price and quantity. You have seen here, value is nothing but the product of price and quantity. Unweighted value index number V01, which is represented as V01, is the ratio of sum of values of the given period expressed as the percentage of sum of values of the base period, and the formula is given by V01, which is equal to sigma V1 divided by sigma V0. It is the sum of the ratio of the values of a given period expressed as the percentage of the sum of the values of base periods. We are going to have only the values of the base period. How to get the value? It is nothing but the price into quantity. The product of price and quantity will give you the value, and the total value is nothing, total value of the current year. This is the total value of the base year. So this is given as V01, which is equal to sigma V1 divided by sigma V0 into 100. V1 is nothing but P1 into Q1, nothing but price into quantity of the current year divided by the price into quantity of the base year into 100. Example, compute value index number for the year 2010 on the basis of 2008 from the following data. We need to compute the index number for 2010 on the basis of 2008 from the following data. So the data is given as 2008, price is given, quantity is given, and these are the items. Price is given and quantity is given of the current year. So here price is given, quantity, so we need to calculate the value of the base year. How to calculate the value of the base year? 9 into 10 90, 10 into 9 90, 7 into 8 56, 15 into 8, and so on. So the solution will go as, that is P0 into Q0, P1 into Q0, P1 into Q1. So P0 into Q1 is that Q0 is nothing but the value V0, and P1 into Q1, this sum will give you the value V1. So value index number is nothing but summation V1 divided by summation V0 into 100, which is equal to, V1 is nothing but summation of P1 into Q1. So P1 into Q1 is there, and summation P0 into Q0 into 100, which is equal to, P1 into Q1 is 404 and P0 into Q0 is 356 into 100, which is equal to 113.48. It means that the total money value of transaction taking place in 2010 is increased by 13.48%. It is increased by 13.48% as compared to the 2008. Next, continue with the test for adequacy of index numbers. Test for adequacy of index numbers. Here there are some of the tests, that is, first one is unit test, time reversal test, factor reversal test, and circular test. These tests are conducted to find an index number which is consistent, whether the index numbers, the various methods, are consistent or not. So this unit test, time reversal test, factor reversal test, and circular test will define us whether the index numbers are consistent or not, whether the methods applied to find the index numbers are consistent or not. Now we will move on to the first method. That is unit test. Unit test, this requires that the index number should be independent of units in which price or quantities of various commodity are quoted. That means this index number should be independent of price or quantities. Either the price or the quantity should be independent where it is quoted. So this unit test is satisfied by all the index numbers. This is satisfied by all the index numbers, that is Laspieres, Pastis, Dorbish-Bowlis, and so on. They all satisfy except simple aggregative price index formula. Except the simple aggregative price index formula, rest all it satisfies the unit test. The unit test satisfies rest of all the formulas. Next is time reversal test, TRT. Time reversal test, it was proposed by Professor Irving Fisher According to him, an index number P01 should be such that when the base year and the current year are interchanged, base year in the sense P01, when you are interchanging it should be P10. The resulting index number should be the reciprocal of the earlier, that is P10 is equal to 1 by P01. P10, which is the reciprocal of P01. This was the earlier and this is the current. So the current, it is the reciprocal of the earlier one. So time reversal test requires that the index number computed backward should be the reciprocal of the index number computed forward. If suppose P10 is the backward, so 1 by P01 is a reciprocal, which will also imply P01 into P10. Bring this to the other side. P01 into P10 is equal to 1. Here P10 and P01 are the mere ratios. They should not be expressed as a percentage. You are not allowed to use in the percentage. Those are the ratios. A formula which satisfies TRT is said to be time consistent. The formula which satisfies TRT is said to be time consistent. Now, which and all will satisfy TRT? TRT is not satisfied by Laspey's, Pasch's and Darvish-Bowley index number. So, TRT is not satisfied by Laspey's, Pasch's and Darvish-Bowley, but it is satisfied by Marshall-Edgeworth, Fisher and Kelly's index numbers. It is satisfied, TRT is being satisfied by Marshall-Edgeworth, Fisher's and Kelly's index numbers. Next, factor reversal test, FRT, factor reversal test. This test was also suggested by Professor Irving Fisher. Factor reversal test requires that the product of price index and the quantity index number should be equal to the corresponding value index number. Factor reversal test suggests that the product of price index and quantity index, price index and quantity index should be equal to the value index. So in TRT, it was P01 into P10, which is equal to 1. Here it is, the condition is P01 into PQ01, which is equal to V01 should be satisfied. It means that the changes in the price multiplied by the changes in the quantity should be equal to the total change in the value. Changes in the price and changes in the quantity should be equal to the total change in the value. Now P01 is nothing but the price index, Q01 is nothing but the quantity index and V01 is nothing but the value index number. Now this FRT is been satisfied only by the Fisher ideal index number. TRT is been satisfied by Fisher's and TRT is been satisfied by the Fisher's as well as the Marshall-Edgeworth and Fisher's, where this FRT is been satisfied only by the Fisher's ideal index number. The last test, it is nothing but the circular test. Circular test, the first it was suggested by Westergaard. It was suggested by Westergaard. It was an extension of TRT. It was the extension of time reversal test for more than 2 periods and is based on the shiftability of the base period. This requires that the index number is to work in the circular manner, and this property enables us to find the index number from the period to period without referring back to the original base each time. For 3 years, if you take 0, 1 and 2, circular test is being satisfied if P01 into P12 into P20. P01, P12 and P20, which is equal to 1, where P01 denotes the price index for the current period, 1 with respect to the base period, 0. Similarly, P1 and 12 and P20, P12 denotes the price index of the current period 1 with the respect to the base period, current period 2 with respect to the base period 1, and here it respects to the current period 2 and with respect to the base period 0. This test is not satisfied by Laspeyres, Paschis, Marshall, Edwards, Dorbish, Bowley's and Fisher indices. This is only satisfied by the simple geometric mean of the price relative and Kelly's fixed weights for Bayes method. This has been satisfied only by the index number formula is been satisfied only by the geometric mean of price relatives and the Kelly's fixed weights for our Bayes method.